Alright, so in this video I want to go ahead and do the rest of the problems that we had in our notes that we weren't able to get to, and so we can just have that resource there. Alright, so we started this one looking at it in class, but I'm going to go ahead and just kind of start from the beginning with it here. Alright, so we have the base of a solid as the region bound by our linear function 3x minus 1 and our cubic function x cubed minus x minus 1. And so we definitely have our red function and our blue function as denoted by the colors in there. So this is definitely g of x and f of x. And so it says, A, determine the volume of the region of each cross-section perpendicular to the x-axis. So that, again, is very important. And we are given this shape. So we can go ahead and kind of draw out that perpendicular cross-section. So I like to draw, when I'm doing these volume problems, I like to draw my, kind of get an idea of where my cross-section is happening. And I know that that cross-section, that kind of length that I mentioned there is going to be f of x minus g of x. Get that full length there. Well, my cross section, if I go ahead and look at my cross sections, that is a square. So I'll go ahead and draw out my square here. So I know that all my sides are congruent. So I definitely have the square. And I have the length here, call b for my base. But remember that that length of the base, that b, is that cross-section that I have within my figure. Okay, so that is that there. So how do I determine what the length of b is? Well, that's going to be just my top function, f of x, minus my lower function, g of x. And then again, I think about how do I determine the area of a square? Well, a of x, the area, is going to be just, well, b squared. It's a square, so b times b is b squared. So then a of x is going to be my f of x minus my g of x, and then I just square that. Now I can go ahead and actually figure out what that is, that polynomial. Wouldn't take too much. So that's going to be 3x minus 1, and I am subtracting all of g. So that's going to be minus x cubed plus x plus 1. All that squared. And so then that would become negative x cubed. That should be plus 4x. And then that should be, the ones cancel out, and so I just have that. That's nice. And that's getting squared. All right, so that is my cross-section and the area of that cross-section. So now I can go ahead and start thinking about, well, now what's my volume? The volume of the shape that is being described here. So volume is equal to the integral from a to b of my area of the cross-section dx. So in this case, a to b, well, it looks like I'm going to be going from 0 to 2. I can just double check on the 2 by setting my functions equal to each other, graphing, and just making sure that I am actually crossing it too. It probably wouldn't be a bad idea to double check that. But I'm going to go ahead and go with what the graph has, just for sake of time. And so then my area function, we already simplified that down there, so that should be negative x cubed plus 4x squared dx. So now I can go ahead and plug that into my calculator. So I'll get my calculator up and running here. All right, so let's see. No. There we go. That's what I want. All right, so I am over here with my volume. That's what I'm doing, right? Okay, so let's go ahead and put this in. My definite integral, so I'm going from 0 to 2. So this is still one that we could definitely do by hand for sure. But just for sake of time, we'll go ahead and just put it in. So that is cubed. So negative x cubed plus 4x. And then that gets squared. Then we need dx. All right, so we are getting a volume of 9.752. That's what we are getting for our volume. Why don't we go ahead and use that 3D rendering program that I was using earlier to kind of just verify that that's what we have. All right, so this is our problem here. We had that problem, okay? So let's see, I should have it in here still. Okay. Looks like I need to reload it. Sometimes this, if it's been sitting for a while, freezes. Let me just go ahead and reload that applet here. I'll need to go ahead and put in some key pieces in here. I need to adjust. Let me go ahead and just do this here. We'll adjust our functions. So we should have 3x minus 1. So right here, 3x minus 1. And then this was x cubed. Let's see. I remember, let's see. X cubed minus x minus 1 is what we had there. So x cubed minus x minus 1. All right, so we have our function in there. Let's see if I can move this down a little bit. There we go. Okay. I do need to change my bounds. So that's going to be from 0 to 2. So we're good there. And then what was our shape? Our shape was a square. So let's go ahead and put in a square. And let's just look at that 3D rendering and we'll check our volume down here. So it's building that shape for us, that volume. And it ends with the volume of 9.75, which is what we got as well. So pretty nice. So we have our 3D rendering of that shape with that volume. I'll go ahead and just draw that again. I think I want to do a screenshot and throw that into the OneNote there. Alright, so let's go ahead and do a screenshot of our 3D rendering. Let's go ahead and copy that. And we'll go ahead and put it on the side here. Or that one there. There we go. Alright. So that one's good. So let's go ahead and look at B. So B is very similar. So it says determine the volume of the region of each cross-section perpendicular to the x-axis if they are rectangles whose height is triple the length of the base. So again, we have the same figure. So we're taking that same base, but as a rectangle, where we know these two sides are the same, but this, so if we label this as B, they're saying the height is triple the length of its base. So this height here is going to be 3 times B. So if I want to determine my area, A of x is going to be 3b times b, or 3b squared. But what is our base? Well, our base is going to be the same as what we had earlier. So since our base is equal to f of x minus g of x, which we already saw that simplifies down to this here, negative x cubed plus 4x, I can go ahead and say that a of x is going to be 3 times negative x cubed plus 4x squared. And so I can go ahead and do my definite integral. So that's going to be, remember, volume is the integral from a to b of the area of our cross-section dx. So volume is going to be, and we're still going from 0 to 2, right, 0 to 2. This time my area is going to be that. So I have 3 times negative x cubed plus 4x squared dx. Now, I'm going to go ahead and just simplify this slightly. So this 3 that I have here could be brought out to the front using that property of integrals. And I have this here. But if you notice, we already figured out what that was. This, at least my integral portion, was right here. It's the same thing. So I can then just say, okay, well then my volume, I already figured out what the volume of it, what the square is. I can just go ahead and triple that. So it'll be 3 times that 9.752. So if I go over to my calculator then, and I eventually turn it on, there we go. So I have the 9.752, and I can just go ahead and take that answer and multiply it by 3. Already did the work there, so why, do it again. All right, so that's 29.257. There we go. All right, so that is B. So let's go ahead and look at problem 3 then. Problem 3, we have the base of a solid as the region bound by the function f of y equals y. Okay. And g of x equals negative y squared, or g of y is negative y squared plus 2y plus 2, as shown in the figure. All right, so hopefully it's pretty clear to see. This is our linear function here. So this is f of y. And then this is my quadratic function, g of y. Determine the volume of the region if each cross-section perpendicular to the y-axis is a square. All right, so I'm going to go ahead and do that. So I like drawing in my cross-section, but this time I have to go horizontally because I need to be perpendicular to the y-axis. Remember, perpendicular means that we create that right angle there. So that's going to be my cross-section base, and my cross-section is a square. So for my cross-section, we would have a square. So it says if I was kind of drawing this, I'd have a square coming out here, and so all these kind of squares coming out and building that solid. That's what's happening here. And like we've seen, that base that I drew on my graph is going to be this base here. So if we label that as b, well, we know it's a square, so they're the same. So a of x is going to be b squared. But how do we express our base? Well, since we are in terms of y, instead of going top minus bottom, I need to go right minus left. So that's going to be my g of y minus my f of y. So let's go ahead and put that in. So a of x is equal to g of y, so the negative y squared plus 2y plus 2. And then we're going to have minus the just y. That's all that we have there. And that's going to be squared. So then that can simplify down to negative y squared. 2y minus y will just give me 1y plus 2 squared. All right, so let's go ahead and build my volume integral. So in volume is the integral from a to b of the area of our cross-section dx. So that's going to be, remember we're in terms of y, so I go from the lesser number, so we're going from -1 up to 2. So that is my bound, so from -1 to 2. And then my area function, we have the simplified version there, so -y squared plus y plus 2 squared. Oh, this is dx. So let's actually adjust the general form here. So that would be a of y dy, and that means I should technically adjust what I have over here because each of these should be in terms of y. A of y, a of y. All right, so everything has the correct variables. All right, so let's go ahead and use our calculator and integrate and figure out what our volume is. All right, so let's see. We are going from -1 to 2. And that's going to be negative. And we can just do x's like we've seen previously. So x squared plus x plus 2. All of that is going to have to be squared. So I should actually probably put in an extra, let's see, second insert. Let's put in a parentheses there so we can actually square all of that, because that is important. So let's square all of that. All right, and x there looks good. Let's go ahead and enter. Oh, syntax. Let's go ahead and go. Where's, oh, yeah, I used the minus. That should be a negative there. Now it should work just fine. 8.1. All right, and that is our volume. Okay, so let's go ahead and look at just one more here. All right, so this one, the base of a solid is a region bounded by the x-axis, the curve ln of x, and the line x equals e. All right, so we see we have that blue curve, so that is our f of x here. That line, the vertical line, is our line x equals e, so that makes sense why it's there, because e is about 2.71, so that's in the correct location as shown in the figure below. Determine the volume of the region of each cross-section perpendicular to the x-axis. Again, yeah, it's important. What are we perpendicular to? Is a rectangle whose height is 4 times as tall as the given base. All right. So let's go ahead and draw that cross-section. So my cross-section is going that way. It is perpendicular to my x-axis. All right, so cross-section is a nice, lovely rectangle. And this is my base. Again, that is the base that I drew here is my base down here. Okay, and then the height. What does it give me for the height? It says the height is 4 times as tall as the given base, so that should be 4b. So how do I find my area? That'd be a of x, and it is a of x this time because I'm perpendicular to the x-axis, so everything is in terms of x. So that's going to be 4b times b, length times width, or base times height, however you want to think about it. That's going to be equal to 4b squared. Okay, how do I express my base? Well, in this one, we're going top minus the bottom. Well, what's my top? My top is that f of x curve that we have, and what is my bottom? Well, the bottom is going to be the x-axis, which is y equals 0. So top minus bottom, my base would be ln of x minus 0, or just ln of x. Pretty nice. All right, so then we can express our area function. A of x is just 4 times ln of x squared. Okay. So let's go ahead and do my volume. So volume, again, remember, is the integral from a to b, a of x dx. And so my volume what are my bounds? Well, I'm going from 1 to that 2.71 or e. So my bounds are 1 to e. And then what is my area? My area right here is 4 times the natural log of x squared dx. So let's go ahead and use our calculator and figure out what that is. So, definite integral, going from 1 to e. And then my integrand is going to be 4 times the natural log of x. I got to close that. Then I have to close that again to square that. And now I can go ahead and go out and end it with the x. And we get our volume at 2.873. Alright, so this one I can actually render in 3D, whereas the one before it, since I was in terms of y, it's a little bit more difficult with the applet that we have, because the applet does everything in terms of x. But I should be able to render this one in 3D. Alright, so we have just ln of x, and that's it. Upper bound, lower bound would be 0. Alright, so let's see, is this still live? It's still live, good. Alright, so let's go ahead. My upper bound was ln of x. So ln of x, natural log of x. Alright, my lower bound was just 0. Okay, so we're seeing that happening down here. I'm going to go ahead and shift this a little bit. Let's go move it over there and kind of maybe zoom in on that area, that region that we're going to be looking at. That's ending at 2.57, so I'm going to need 2. There we go. So 2.5, I want it to, because we're going to be ending at 2.7. So lower bound is not 0. That is 1. Upper bound is going to be E. I should just be able to put the letter E. Go. And then what were we doing? We're doing rectangles. So let's go ahead and look back at that here. So what was our base? Okay, so our base, let's see, rectangles. So we're going to do rectangles with the height. Height was 4b. Our base is just ln of x. So I should be able to just put 4 ln of x. So 4 ln of x. Okay, do that rectangle. Alright, so hopefully I'm going to change this just a little bit. It should draw that solid. Perfect. It's exactly what I want. It's going to keep on growing. I might have to zoom out a little bit. So, yep, not seeing the top part of that. So let's zoom out just a little bit so we can see. There we go. Perfect. Let's draw that shape again. All right. Let's see what we remember. Remember we had our volume was like 2 point something, right? Alright, there is our shape stopping at E. Pretty nice shape drawn there, right? And they're saying volume is 2.87. What did we get? We also got 2.87, so fantastic. Alright, well, we'll go ahead and end the video there. Hopefully that was useful and informative. I'll give a couple more examples, along with some visuals of how these problems work. All right. Well, have a wonderful day, everybody, and we'll see you guys later.